Good afternoon, everyone. I am Suman Lata, Assistant Professor, CSE Department, made Maharaja Agrawal University. Today, I am going to deliver a topic that is from computer network, that is error detection and correction in computer network. The topic which we are going to cover in this are overview of computer network errors, types of errors, error detection, correction, forward error correction versus retransmission, coding, modular arithmetic. First of all, let's start with the overview. Data can be corrupted during transmission due to errors. Errors are introduced into the binary data transmitted from the sender to the receiver due to noise during transmission. Some applications require that errors be detected and corrected. Errors in communication. When the information received at the receiver's end does not match the sent data at that time of transmission, errors are introduced into the binary data sent from the sender to the receiver due to noise during transmission. This means that a bit having a 0 value can change to 1 and a bit having a 1 value can change to 0 and vice versa. Now, next is types of errors. The error can be a single bit error, multi-bit error, or burst error. Error detection methods are used to check whether the receiver has received correct data or corrupted data. Error detection method used to detect whether we have received original data or not. And error correction is used to correct the detected errors during the transmission of data from sender to receiver. Types of error. Next, some errors that occur during communication are given below. First is single bit error. Typically, only one bit of the frame received is corrupt, and the corrupted bit can be located anywhere in the frame. As the figure is shown here, the bit sequence which is sent from the sender side is 10110011, and at the receiver's end we have received 10110111. The bit which I have highlighted in pink color is corrupted because only one bit is erroneous or there is a change in this value of bit. This is single bit error. Second error is multiple bit error. When more than one bit received in the frame is found to be corrupted, then the error type is known as multi-bit error. Next is burst error. More than one consecutive bit is corrupted in the received frame, then the error type is known as burst error. Like in the figure, we have shown 10110011 from the sender side, and at the receiver's end, we have received 1100. So all three bits are in pink color, showing that there is burst error because more than one consecutive bit is corrupted in the received frame. And this type of error is known as burst error. Now, we have three type of error as I have discussed: single bit error, multi-bit error, and burst error. Which type of error is occurring in the network? We can detect that error. And the next topic is error detection. Simple parity check. The method is simple parity check. Here, data sent from the center undergoes parity check. One is added as a parity bit to the data block. If the data block has an odd number of ones, 0 is added as a parity bit to the data block if the data block has an even number of ones. Means if we have odd number of ones, we have to add 1 as parity bit, or if we have even number of 1, we have to add 0 as parity bit. This procedure is used for making the number of ones even. This is commonly known as even parity checking. This method is known as even parity checking. Refer to the figure here. Sender, and we have sent 100011, compute parity bit 100011. Now we are transmitting the bit with adding additional 1 because in the sender there is number of ones are odd So we have to add one more bit and compute the parity check. If the sender's data and the parity bit data is same, then the data is accepted and the receiver accept the data. Otherwise, if the number is not even, the data is rejected. This is our simple parity check method. Disadvantages of single parity bit. Only single bit error is detected by this method. It fails in multi-bit error detection. It cannot detect an error in case of an error in 2 bits. Only single bit error is detected here. Refer to the figure below. Disadvantage of simple parity checking method is we have sent 10110011 and we are receiving 11000111. Here, there are three consecutive bits are erroneous, but the single bit error or simple parity check method does not identify this type of errors. Next is two-dimensional parity check. Two-dimensional parity check, for every row and column, parity check bits are calculated by a simple method of parity check. Parity for both rows and columns is transmitted with the data sent from the sender to receiver. At the receiver side, parity bits are compared with the calculated parity of the data received. Here is the figure, original data, and here we have two-dimensional parity check where there is combination of row and column parities, and then after calculation data is to be sent. Disadvantages of two-dimensional parity check is if two bits are corrupted in one data unit and another data unit exactly at the same position is corrupted, then this method is not able to detect the error. Sometimes this method is not used for detecting 4-bit errors or more than 4-bit errors. Next method for error detection is checksum. Checksum is an error detection method which detects the errors by dividing the data into segments of equal size and then use one's complement to find the sum of the segments, and then the sum is transmitted with the data to the receivers and same process is done by the receivers, and at the receiver side all zeros in the sum indicate the correctness of the data. First of all, data is divided into k segments in a checksum error detection scheme, and each segment has m bits. Sender side, all segments are added through one's complement arithmetic, and for determining the checksum, we complement the sum. Along with data segments, the checksum segments are also transferred. All the segments that are received on the receiver side are added to one's complement arithmetic to determine the sum, then complement the sum. The received data is accepted only on the condition that the result is found to be 0. And if the result is not 0, then it will be discarded. Refer to the diagram here. As I have already discussed, here this is the sender bit sequence and this is the receiver's bit sequence. By adding the ones complement and number of zeros, we can check whether we have to select or accept the data. Disadvantages. In checksum, error is not detected if one sub-unit of data has one or more corrupted bits and corresponding bits of the opposite value are also corrupted in another subunit. Error is not detected in this situation because in this case, the sum of column is not affected by the corrupted bits. Next detection method is CRC. CRC stands for cyclic redundancy check. As this shown in figure, we have data plus n number of bits that are known as CRC. We select some random bits for divisor and CRC is calculated. Then data plus CRC is sent to receivers end. At receivers end, data plus CRT is received and same divisor is used to calculate the remainder. If the remainder is 0, the value is accepted. If remainder is not 0, the receiver end does not select the data. The data will be rejected from the receiver side. Cyclic redundancy check The checksum scheme uses the additional method, but CRC uses binary division. A bit sequence commonly known as cyclic redundancy check is added to the end of the bits in CRC. This is done so that the resulting data unit will be divisible by the second binary number that is predetermined. The receiving data unit on the receiver side need to be divided by the same number. These data units are accepted and found to be correct only on the condition that the remainder of this division is zero. The remainder shows that the data is correct, so they need to be discarded. This is the diagram for CRC. Disadvantages are cyclic redundancy check may lead to overflow of data. Next is error correction method. When the data is sent from the sender side to the receiver side, it needs to be detected and corrected. So an error correction method is used for this purpose. Following are the methods for correcting the errors. One is backward error correction and another is forward error correction. In this method, when any error is found in the data at the receiver's end, then the request for resending the whole data unit is sent by the receiver. Next is backward error correction. In this method, an error correcting code is used by receiver that automatically correct the errors. Thanks.